The Moisture Mavericks are a team of students who came together to engineer a wearable sweat sensor tailored to aid in future glucose monitoring endeavors. The team was made up of individuals with a variety of coursework and in-field experiences. Members include Tabitha, Timothy, Carrie, and Aaron. Three main problems with devices in the existing wearable hydration monitoring market were identified. Current models are reactive, require secondary devices to decode the data, and are environmentally unfriendly. Professor Highhath has worked to develop a sensor intended to detect glucose using sweat, with the goal of developing a wearable, non-invasive glucose monitor. Our task was to develop a wearable which could be used with his team's sensor in the future. As a secondary goal, our team has chosen to focus on detecting sweat, which targets users from demographics like athletes, the elderly, and workers.
Our hydration monitor will combine temperature, humidity, and sweat rate information in a wearable device on the wrist, displaying information real-time to the user. This uniquely merges ambient conditions with sweat metrics to monitor an individual's cooling during activity. For the hardware, we used a pre-built ESP32 microcontroller with the built-in touchscreen and battery management circuitry. The device will also use a custom-designed sensor board that will contain 2 temperature sensors and a skin resistance sensor. The device's key functional areas are its data acquisition of both user and sensor data, sweat rate calculation, and the user experience. Putting these together into the proof of concept showed the design idea to be valid with full communication to all 3 sensors and a display interface that was expanded to show more information as the project progressed.
The team had to master several technological aspects, including learning how to use the AD5933 for skin impedance measurement and working this circuit into a wearable design. After studying approaches used by other researchers when calculating sweat rates, the Moisture Mavericks adopted an approach that uses height, weight, temperature, and skin resistance. Heat index data is widely available for a range of climates, and this data is used in our device to inform the wearer about safety conditions. A custom circuit board has been developed to interface temperature, humidity, and skin resistance measurement circuits with the LilyGo microcontroller and display. The custom printed circuit board design was manufactured in China and assembled in New Mexico. Research and development continued in New York and South Carolina.
The final product continuously monitors the sensor readings and transmits the data to the display screen in real time. The results are cross-referenced with the heat index chart and color-coded for better visualization of hazardous conditions, enabling the user to make informed decisions about hydration or activity level. Here we have a demo that shows the date and time as the default startup screen. Using the device's touch capability, the user can swipe between viewing screens to see either the raw sensor data or the heat index and calculated sweat rate. The user interface includes a menu to input the user's height and weight and set certain display parameters. Design challenges identified that could be optimized in the future are the effective heat dissipation on the sensor readings and alternative methods for the skin resistance measurement. In conclusion, our team has successfully produced a wearable device that actively monitors an individual's sweat rate and alerts the user to adverse conditions. Our device is intended to be used in conjunction with our mentor's existing research in non-invasive glucose monitoring. Our team is proud of the work that has been completed and excited to see what the future holds.